So let's pick up on the next one. Now look, okay, so secant of x plus 1 over tangent of x equals sine of x over 1 minus cosine x. Are those in fact equal? That's what we're trying to find out. Are they equal? Yes or no? Can we get one to look like the other? So they look like they have equal amount of complexity, both left or right sides. However, because, again, thinking about what's on those sheets, secant of x and tangent of x can be written in terms of sine and cosine. So let's work on that. So now secant is the reciprocal of cosine of x, and tangent of x is the sine of x over cosine x. Now you can see how this is a whole lot more complex, this side, and we did it that way on. Okay, so now, okay, what do we do? Well, you have a couple different options with the complex fraction. You can get common denominators and then divide. So do the additions, if there's additions or subtraction, and then end up dividing. You can also, and this is the way I like it because you get rid of the denominators right away. What is the common denominator of all of those? Individual. Well, it's cosine of x. So I'm going to multiply the numerator and denominator by the cosine of x. Notice it's like this here. That's really what you're trying to do. So when you multiply this out, cosine x times 1 over cosine x, cosine x times 1. Now, sine of x over cosine x times cosine x over 1, well, this. Close. Better, but close. Okay. Now what? Well, for me, this is where taking a peek on the other side is going to be helpful to me. I see right here, the numerator, we have sine x. We don't have that here. So, quick way to get that is multiply both the numerator and denominator by the sine of x. Again, what is this number right there? What is that number right there? Strange names for one. So we're not changing any value. So we're going to say, okay, how is this going to be helpful? I have this here, and then the sine squared of x. Well, at least we got that part now. What comes next? Well, taking a look at one of these Pythagorean identities, because when I see squares, trig function squares, and with a possibility of 1, I'm thinking that. Well, what is the sine squared of x equal to? Now these identities, we know. Those identities on that sheet, we know. This is true for a fact. 100% true. We know that, we know that, we know that. We don't have to verify it. We don't have to do any of that. We could. Actually, we will later on go through where this comes from. And yes, Pythagorean theorem is it. Okay, so I'm going to go ahead and substitute. So in place of sine squared of x, and the denominator, I'm going to replace it with 1 minus cosine squared x. Again, maybe not writing it that way would be beneficial. Maybe writing it as this would be better. Wait, multiplication over here. The way we get rid of multiplication is cancel, reduce, take out common factors. So can we factor the denominator? Hopefully we can. So when we do we can get rid of that factor here, because that's the one that's missing in the original numerator. Oh wait. 1 minus something squared. This is a difference of two squares. What's squared for the first? What square is going to get you 1? What square is going to get you cosine squared? Cosine of x. 1 plus, 1 minus. Hey look, a funny name for 1 right there. Bye bye. Ta-da! And looking all the way back up the first, it's what we had. So this identity has been cubic checked. So this thing here is in fact equal to this here. So if I'm evaluating something, yeah, complexity, the number is about the same. However, I know sine values, I know cosine values a lot better than the secant and the tangent values. So we could replace that with the other. So yeah, sometimes they get a little bit longer. But again, it's just a matter of what you have. Again, recapping it, why did I change? I used the left side because the right side has sine and cosine. It'd be nicer for me, that I think of, is to change this than trying to get sine and cosine into secant and tangents. A little bit more complex, but if I can change secant and tangents into sines and cosines, I could work with that a little better. Okay, again, trying to see what you got. Oh. I gotta add in the last one. So this fraction, the sum of these two become 2 cosecant of t. No, the left side is not 1. You are adding. How do we add fractions? The only thing for the common denominator is, oh, that was nice. In this case, since 1 plus cosine of x, cosine of t, I have a problem. The only common denominator is their product. So what do we need in this first denominator to get this? Yep, sine of t so that's sine squared t plus. What do we need in this denominator to get that? So it's 1 plus cosine of t quantity squared. Now, the more we do with this, the more your algebra issues, let's put it that way, your algebra shortcuts that may not be true or other things like that will come out. So you got to be pay close attention to the algebra. So the algebra with the trigabra. Okay, nothing to do with the sine squared of t. Square that. Again, you can take 1 plus cosine t times 1 plus cosine t, multiply it all out, or shortcut 1 squared then 1 times cosine of t times 2, and then cosine of t squared. I say, how in the world are we going to get 2 cosecants of t? We'll see. We'll get there eventually. Okay, no common fact, or sorry, no like terms to cancel, or not cancel, to combine, I should say. However, sine squared of t plus cosine squared t. That's one of our. That's the big identity. Now, I've known some students who like to take that and rewrite it, put them together, close together, but that is 1. So we'd have 1 plus 1 plus 2 cosine of t. Again, this may be one step that you say, I don't have to do. It's not necessary for me. Okay, I can understand that. And go to this here. Closer. I see a 2, and I see where the cosecant's coming in of t, because it's a reciprocal or over sine of t. But I got this. Again, what do you see? Can you, if you can recognize it, do it. If you don't recognize it, and this is better, numerator has a common factor of 2. Yep, I am not kidding you. Ta-da! Oh, look. Wait, weird name for 1. You're gone. So, 2 over the sine of t is 2 cosecant t. And that's what we had original. So it is been QB checked. Again, recap, where are your trig steps? Your trig steps occur right here in the identity to get that identity for that 1. And then the identity right here, going from over sine of t to cosecant of t. That's it. The rest of that, believe it or not, is algebra with strange looking numbers. Okay? So, again, work on it, crank it through. You may have to slow down on your algebra. That's fine. That's understandable. That's, quote, expected. And expect to get, and what happens if you run into a brick wall? Try something else. Good luck on those.